Okay, today we are going to start surface integral, right? So in the previous video, that is in yesterday video we have solved Green's theorem. So we have solved 7 problems on Green's theorem, and still there are 3 to 4 problems in textbook. So I think you can do that, right, very easily. Now we are going to move on to surface integral, right? Yes. So surface integral. Now first we have started with the gradient, and then we have started divergence, and then curl, and then we move on to a line integral, right? Yes. And then we move on to Green's theorem. So Green's theorem connects line integral and double integral over R, dou n by dou x minus dou m by dou y dy dx. So here now we are going to study surface integral, right? Surface integral and volume integral. Surface integral and volume integral. Yes. So first let me write out the formula for surface integral. Yes, the formula is, so double integral over S del cross f dot n ds. Right? This is a formula to find the surface integral, right? This formula to find surface integral. So suppose they can also give double integral over S small f dot n ds. So small f means del cross capital F. Suppose if they give small f means you can straightly substitute here. Suppose if they give capital F means you need to find del cross f, right? Yes. Now we need to find 3 things. So first, if they are given capital F, we need to find del cross f, and then we need to find n, and then we need to find ds, and we need to substitute here. That's it, right? Yes. Now again this is same as this, right? You don't need to find LHS and RHS. This is another way to denote del cross f by small f, right? It is not LHS RHS, it is nothing but the surface integral over S. Now we need to find n and we need to find ds, right? So first we need to understand what is meant by n, right? So n is so we need, how we will find n is, so n is equal to gradient of surface. So they will give some surface like cylinder or sphere, they will give some surface like this. So you need to find the gradient of that surface by modulus of that surface, right? Modulus of that surface. Right? So gradient of that surface by modulus of great surface, sorry, modulus of gradient of surface, right? So you know how to find modulus. So modulus of xi plus yj plus zk is equal to square root of x square plus y square plus z square. So you need to find n using this formula. So gradient of that surface by modulus of gradient of that surface, and we need to find ds. So ds you can choose either dx dy by modulus of dx dy by, suppose if we are missing z, you can write that as n dot k, or you can also choose ds to be equal to dy dz. So you have missed x here, so that means n dot I, or you can also choose this to be dz dx by n dot j. You can choose any one to be equal to ds depending upon the question, right? So this needs practice. So in some problem we will choose this, some problem we will choose this, in some problem we will choose this, but you can choose any one of them, you will get answer. But if you choose appropriately, you will get the answer very easily, right? Yes. So this is how the working method. So if they given capital F means we need to find del cross f, and n can be found using this formula, and ds we have to choose any one among this, and if they given small f means we don't need to find del cross f, so it is enough to find n and ds. So we will move on to the first problem now. So evaluate double integral over S. Okay. So just note on the formulas. So we will move on to. So first problem is evaluate double integral over s f n ds f dot n ds where capital F is equal to 3 by 8 x y z and s is the surface of the cylinder and s is the surface of the cylinder. X square plus y square is equal to 16 included in the first octant between z is equal to 0 and z is equal to 5. So this is the problem, right? So we need to evaluate double integral over s f dot n ds where f is 3 by 8 x y z and s is surface of the cylinder. Let us say this is our z axis, this is our x, this is our y. So this is the surface of the cylinder. So this is z is 0 and z is 5 in the first octant, right? Yes. Now you can see they are given small f. So they are given small f. So we don't need to find del cross f. So first we need to find so they are given solution. Now so they are given f is equal to 3 by 8 x y z. Now we need to find n. So what is n? It is gradient of surface divided by modulus of gradient of surface. So what is gradient of surface? So it is gradient of what is surface they are given? They are given x square plus y square, right? X square plus y square. So you don't need to write constant, right? Because we take gradient, it will be 0 again. So gradient of x square plus y square divided by gradient of x square plus y square. So this is nothing but 2x I vector plus 2y j vector. So you will differentiate the first component with respect to x and then you need to multiply I vector. This is normal gradient, right? Now determinant of this. So determinant of modulus of 2x I vector plus 2y j vector. So this is nothing but 2x I plus 2y j divided by square root of modulus of xi plus yj is equal to square root of x square plus y square. So this will be square root of 2x whole square plus 2y whole square. So this is 2x I vector plus 2y j vector divided by square root of this is 4x square plus 4y square. Now I can take 4 outside. So when I take 4 outside, this is 2x I vector plus 2y j vector. Now if I take I can write that term as 2 times square root of x square plus y square, right? I can take a root 4 outside. So we have 2 times square root of x square plus y square. So the given x square plus y square is equal to 16. So if we substitute 16 here, root 16 is 4. So overall we have 2x I vector plus 2y j vector by 16, right? This will be square root of x square plus y square is 16. Root 16 is 4. 4 into 2 is 8. 4 into 2 is 8. So this is our okay. Now I can also take 2 outside here. So this will be xi vector plus yj vector by 4. So I can take 2 outside and I can cancel with the denominator 8. So this is our n. So n is xi vector plus yj vector divided by 4. Now we need to find ds, right? We can choose ds to be dx dy by n dot k or dy dz by n dot j or dz dx by n dot k. Now we can see I am going to choose here. You can see they are given z limit 0 to 5. So if I choose dz means for dz I can substitute limit to be 0 to 5, right? So I can choose dz and you can choose dx or dy either. So I am going to choose dx dz, right? Yes, now I'm going to choose ds to be, you can also choose dy dz, or you can also choose, but they have given the z limit, right? So we will fix dz as one term. So from dx dy you can choose anything. Now I'm going to choose dx and dz. So our ds is dx dz divided by n dot j, right, because I have missed y, n dot j. So what is our n? N is xi plus yj, n dot j. So what will be our n dot j? So it is dx dz divided by, or we will choose dz dx, right, both are same, dz dx dz dx. So n dot j, so n is xi plus yj by 4. So if you make a dot product with j, I will have y by 4, right, I will have y by 4. So I can see this is our n. So if we make a dot product with j, so jj will be 1, so we have y by 4. So n dot j is y by 4. So we have found ds, we have found n, so we can substitute in this formula. So therefore this is our n, this is our n. So we have, so double integral over s f dot n ds. So this is double integral over s. So our f is 3 by 8 x y z dot n is xi plus yj plus zk. So xi plus yj by 4, this is our n, and our ds is dz dx by y by 4, dz dx by y by 4. Now this will be double integral over s. So we need to simplify this. So if I simplify this, this will be, if I take a reciprocal, this will be 4 by y, and this y will get cancelled. So we have, okay, we will simplify this. So you can see this is 3 by 8 x y z into xi plus yj divided by 4 into 4 by y dz dx. This y and this y will get cancelled, this 4 will get cancelled. So we have 3 by 8 outside, so 3 by 8 you will have outside, double integral over s. So overall we have xz here, so we have only xz here. So if you multiply this here, we will have x square z I vector and xz into this, that means x y z j vector into dz dx or dx dz, right, dx dz or dz dx, okay, dz dx. So you can see we are only integrating this with z and x, but we have y here, right? So we need to transform y in terms of z or in terms of x. So I am going to write this as 3 by 8. So we have x square plus y square is equal to n. That means I am going to transform y as square root of 1 minus x square. So I am going to transform y as square root of 1 minus x square. So because we are integrating with respect to dz dx, but we have y, so we need everything transform that. So we have double integral over s x square z I vector plus xz, in place of y I am going to write square root of 1 minus x square. Sorry, it is 16, right? It is 16. So we have y square is equal to this 16. 16. So therefore I can replace y as 16 minus x square whole power 1 by 2. So I am going to replace this as 16 minus x square whole power 1 by 2 j vector into dz dx. Now you can see we need to integrate this, right? So when you integrate this, you can see first limit is dz. So you can see z varies from 0 to 5 and we need to find x. So in order to find x, what you need to do is you simply substitute y is equal to 0, right. So if y is equal to 0, the maximum bound for x will be 4. Therefore the x will be from 0 to 4, right. Yes. So when you integrate this, we will get the required answer. Yes. So first we need to integrate this with respect to z. Now you can see that I can take z outside here, right, because z is common. So I can write this as So I can write this as 3 by 8 integral 0 to 4 integral 0 to 5. I'm going to take x square I vector plus x into 16 minus x square whole power 1 by 2 j vector, and I am going to take z outside into dz dx into dz dx. Now we will integrate with respect to z. So this entire term will be constant because every term does not contain z. So we have this to be 3 by 8 integral 0 to 4. This will be x square I vector plus x into 16 minus x square whole power 1 by 2 j vector, and integration of z is z square by 2. The limit is from 0 to 5 dx. So this will be 3 by 8 integral 0 to 4. So this will be 25 by 2. So I can take 25 by 2 outside. So we need to integrate x square I vector plus x into 16 minus x square whole power 1 by 2 j vector into dx. So we need to integrate this term and then we need to substitute upper limit and the lower limit. So we will do that. Now this will be 3 by 8 into 25 by 2. So when I integrate this, this will be x cube by 3. Limit is from 0 to 4 I vector. Now here x cube by 3 again I need to apply uv here, right, because uv minus integral v du, that's what I need to do here because we have x here. Yes, you need to apply uv here. So integral uv. So when I apply integration by parts, you have this to be u into v. So when I integrate this, we will have 60 minus x square whole power 3 by 2 by 3 by 2, and I need to differentiate inside, right. So it is into minus 2x minus integral v du. So v du is v is again 60 minus x square whole power 3 by 2 by 3 by 2 into minus 2x into dx. So again it is so again we need to integrate u by v. So I think we need to again integrate u by v. me do one thing. So if you go by this, it will be very long, right? So what I will do is, before integrating, what you will do is, you will slightly alter the term. I can write this term as, so I can write this term as minus 1 by 2 minus 1 by 2, let us this as it be 16 minus x square whole power 1 by 2 into minus 2x. You can see I have written x as minus 1 by 2 minus 2x. So this 2 will get cancelled, minus minus will be plus x. Now when I integrate this, what I will have? This is integration of this. We have integrated this term. Now we are going to integrate this term. So before that, I am just altering x. I am writing x to be x as minus 1 by 2 into minus 2x. So this will be 3 by 8 into 25 by 2, and this is nothing but 4 cube by 3. So 4 cube is 64. 64 by 3 I vector. Now when I integrate this, you can say I can write this term as I will take minus 1 by 2 outside. So this is integral 0 to 4 16 minus x square whole power 1 by 2 into minus 2x j vector. Now I can write this term as, when I integrate this, you can see already minus 2x is here. So I can write this term as 3 by 8 into 25 by 2, and so this is 64 by 3 I vector minus 1 by 2. Now I can write this term as, when I integrate this, it will be 16 minus x square. So it will be 3 by 2 by 3 by 2, right? I can straightly write this term as 16 minus x square whole power 3 by 2 by 3 by 2. So I don't need to use UV here, because you can see the derivative of this is minus 2x, right? So it is enough to only integrate this term into j vector. The limit is from 0 to 4, right? So whenever you have this term, you try to make minus 2x here. So if you take minus 2x here, you can only integrate this term, right? That's what I am doing here. Now when you need to substitute 4, upper limit is 4. So you can see when I substitute upper limit, this will be 0, right? Because 16 minus 16 is 0. So when I substitute lower limit, we will have this to be equal to 0. So we have 3 by 8 into 25 by 2, 64 by 3 I vector minus 1 by 2 into 2 by 3. So I have taken this 3 by 2 as 2 by 3. Now the upper limit will be 0 minus lower limit. So lower limit is 16 minus 0. So 16 whole power 3 by 2. So I can write 16 as 4 square. So 2 will get cancelled. So we have 4 cube. So which is minus 64. So this term is minus 64. So overall we have this is 3 by 8 into 25 by 2, and this is 64 by 3 I vector, and here we have this 2 will get cancelled. So we have minus 1 by 3 64 j minus 64 j vector. This will be plus. And this is the required answer. So when I make some simplifications, so I take 64 by 3 outside. So we have 3 by 8 into 25 by 2 into 64 by 3 I vector plus j vector. So when I cancel this term, so 3 will get cancelled. So 8 ones are 8 8s are 2 ones are 2 4s are. So we have 100 I vector plus j vector. So this is the required answer. So we will move on to the next problem. So I will move on to the next problem, which is so evaluate double integral over S f dot n ds where f is equal to y into I vector plus 2x j vector 2x j vector minus z into k vector, and S is the surface of the plane and S is the surface of the plane 2x plus y is equal to 16 or 6 in the first octant cut off by the plane z is equal to 4. So 1 minute, I will fill the ink. So first we need to find a double integral over S f dot n ds. So first we will find n. So what is n here? So n is gradient of the surface. So the surface as 2x plus y divided by modulus of gradient of surface. So this is 2x is 2I vector plus j vector. Derivative of x is 2x plus y plus 2z is equal to 6. So just change the question, 2x plus y plus 2z. So 2x plus y plus 2z. So gradient of this 2x plus I plus 2k vector divided by modulus of 2I plus j plus 2k. So this is 2I vector plus j vector plus 2k vector by square root of this is x square plus y square plus z square. So we have 2 square plus 1 square plus 2 square. So we have 2y vector plus j vector plus 2k vector divided by, so this is 4 plus 1, this is 9, right. So we have root 9. So root 9 is 3. So therefore our n is 2 by 3 I vector 1 by 3 j vector plus 2 by 3 k vector. This is our n. Now we need to find ds, right. So again I am going to choose ds as dz dx by n dot j, because I have one bound z as 4, so I can take z limit as 0 to 4. I can take z limit as okay, cut off by the plane. So because we have only upper bound, right, we don't have lower bound, so we will take not dz. So if we take dz means we need lower bound, right, we don't need lower bound, so we will choose dx dy, right, dx dy. Actually, I have changed the problem. Actually, it is 2z only. Right, it is 2z only. It is not. Actually, I have mixed two problems. Okay. 2x plus 5 only, right? 2x plus 5. So this is 2I vector plus j vector by modulus of 2I vector plus j vector, and this is 2I plus j divided by square root of x square plus y square, so which is root 5. This is our n. We will take, we have only x and y, right? So again, yes, so we will take z is equal to 4. So if z is equal to 4, so what we will do is we will take ds to be same. So ds is equal to dz dx by n dot j. So yeah, I can find x here, right? So I can find x here by y minus 6 by 2, right? Y minus 6 minus y by 2, and dz I can rent from 0 to 4, 0 to 4. So this will be dz dx by n dot j. So n dot j will be n dot j. So n is this. So when I make a dot product with j, we have 1 by root 5. So this is nothing but root 5 dz dx. So we need to find a double integral over s f dot n dx. This will be double integral over s f dot n ds is equal to double integral over s. So what is f? So f is yi vector plus 2xj vector minus zk vector. N is 2I plus j by root 5, and ds is dz dx divided by n dot j, that is root 5 dz dx. So this root 5 will get cancelled. So when I make a dot product, with these two terms, we have double integral over s. So this is 2y, right? Y into 2 is 2y, and 2x into 1 is 2x, and we don't have z here, so this will be 0 into dz dx. So this I can write this as, I can take 2 outside, so double integral over s y plus x dz dx. Now you can see z varies from 0 to 4, right? Cut off by the plane. Z varies from 0 to 4. So z varies from 0 to 4, and to find y, we need to find x limit, right? So for x limit, they are given that 2x plus y is equal to 6, that means 2x is equal to 6 minus y, that means x is equal to 6 minus y by 2. So I can vary x from this, y is equal to 6 minus 2x, or what I will do is, okay, what we will do is, we will, because we have y here, right, we will have y here, So what we will do is, without finding x limit, what we will do is, x varies from 0 to 1, we will try to transform y in terms of x, because that's what we did in the previous problem also, right? So we need to transform y in terms of x. So we have 2x plus y is equal to 2x plus y is equal to 6. That means y is equal to 6 minus 2x. So this will be 2 times double integral over s. So in place of y, I am going to write 6 minus 2x plus x into dz dx. So this will be 2 times double integral over s, double integral over s, double integral over s. So this is 16 minus x dz dx. Actually, if they are given double integral del cross f n ds, you find del cross f, or else you don't find del cross f, right? So the starting they have used different notations in the book, right? So from now on, if they asked us to find only this, you find del cross f, right? Otherwise you don't find cross, either it is capital F or small f, no problem. So if they ask us to find f and ds, you find f and ds or this alone. So if they are given like this, you find cross, or else you don't find cross, right? So either capital F or small f, no problem. So this will be we need to find x limit and the z limit, right? So clearly z limit is from 0 to 4, right? Z limit is from 0 to 4, and for x limit we need to substitute 2x plus y is equal to 0, right? This is a surface. For 2x plus y is equal to 6 is a surface. So to find the x limit, put y is equal to 0. So we have 2x is equal to 6, that means x is equal to 3. So that means the limit for x is 0 to 3. So this will be 2 times integral. This is what we have done the previous problem also. So for finding the y limit or x limit, we will put next other term to be equal to 0. So I can take 16 minus x as constant. So integration of dz is z, and z varies from 0 to 4. So this will be 8 integral 0 to 3 16 minus x dx. So this will be 8 times 16, this will be 3 minus x square by 2, it will be 3 square by 2, and this will be 8 into 48 minus 9 by 2. 6 minus 6. This will be 18 minus 9 by 2. So again this will be 8 into 18 into 2 is 36. 36 minus 9 by 2. 36 minus 9 by 2. So this will be 4. So 4 into 27, which is 108. So 108 is the required answer. So we'll move on to the next problem. The third problem is evaluate double integral over s f dot n ds, where capital F is equal to 18zi vector minus 12j vector plus 3yk vector, and S is the surface of the plane, and S is the surface of the plane. 2x plus 3y plus 6z is equal to 12 in first octant. Now if you look at the previous problem and this problem, so in previous problem we have a plane cut off by z is equal to 0 and z is equal to 5, but here you can see there is no any bound for z. So in ds we will not take dz, right? So we will take dx dy or dy dx, right? So first we will find one by one. So they are given, they evaluate double integral over s f dot n ds. So first we will find n. So n is gradient of surface. So 2x plus 3y plus 6z divided by modulus of gradient of 2x plus 3y plus 6z. So this is nothing but 2i vector plus 3j vector plus 6k vector by square root of 2 square plus 3 square plus 6 square. So 36 plus 4 plus 9, so 49, so which is 7. So we have 2i plus 3j plus 6k by 7. Now we will choose ds to be equal to dx dy by n dot k, because we don't have a z bound, right? So we will choose dx dy by n dot k. You can also choose that also, but that will take more time to integrate, right? So dx dy by n dot k. So what will be my n dot k? So n dot k is 6 by 7, right? N dot k is 6 by 7. So dx dy by, so n is 2i plus 3j plus 6k by 7. So n dot k, so that will be 6 by 7. So this is nothing but 7 by 6 dx dy. Now we will find f dot n ds, right? So we will find f dot n. So it will be easy for us to, okay, we will show in a single stroke. So integral over s f dot n ds. So this is double integral over s. So what is f? So f is 18z I vector minus 12j vector plus 3yk vector n. So n is, so I can take 1 by 7 out. Okay, we will write 7 here. So 1 by 7 2i plus 3j plus 6k and ds. So ds is 7 by 6 dx dy. So this 7 will get cancelled. So I can take 1 by 6 outside. So double integral over s. So 18z into 2. So we have 36z minus 12j into 3. So we have again minus 36j. 3y into 6 is 18k vector. Sorry, j minus 12 will not 36. So 3y plus 18y. Right, we are making dot product. So I quotient 18z into 2 is 36. So 36z minus 36 plus 18y into ds is dx dy. Now we need to find x limit and y limit, right? So we need to find x limit and y limit. Now we can find x limit by substituting y is equal to 0, z is equal to 0, right? So we can only find the last limit. We can only find the first variable limit by substituting y is equal to 0, z is equal to 0, right? Suppose if you want to find a z limit, you should not substitute x is equal to 0, y is equal to 0. So this method only works for the first variable. So here the first variable is x. So we can find x limit by y is equal to 0, z is equal to 0, right? So again, if you want to find z limit, you cannot just substitute x is equal to 0, y is equal to 0, right? Important point. Now we can find x limit by substituting y is equal to 0, z is equal to 0. That means x is equal to 6. That means x varies from 0 to 6, right? X varies from 0 to 6. Now again you can see this integral does not contain z. So we need to convert z in terms of x and y. So from here I can convert z in terms of x and y, and then we need to find x limit and the y limit. So x limit is clearly 0 to 6. So y limit we need to find, right? Yes. So this will be 1 by 6 double integral over s. So in place of z, so we have 2x plus 3y plus 6z is equal to 12. That means 6z is equal to 12 minus 2x minus 3y. That means z is equal to 1 by 6 12 minus 2x minus 3y. Now I need to substitute z is equal to 12 minus right. So we need to substitute z. Now we need to find z, right. So z is 1 by 6 12 minus 2x minus 3y, or else what we can also do is we need to only evaluate in the first octant, right. We need to evaluate only in the first octant. So in the first octant we will don't have a z term, z is always 0 in the first octant, right. So we can also use that method also. So we don't need to write like this, because in first octant the first octant the z will be 0, right, because we are evaluating only in the first octant. So what we can do is we can simply put z is equal to 0, that is what I think, because we evaluate in the first octant. So if I put z is equal to 0, we will have minus 36 plus 18y dx dy. So in first octant z is equal to 0. So in first octant we have only x and y, z is equal to 0. So I think now the problem will be very easy for us. Let us do by this method, whether you will arrive at, whether you will see whether you will arrive at this answer or not. Is first octant that is equal to 0. Okay, before that, so I am not sure that in first octant that is equal to 0. So just try with z is equal to 0 and whether you will verify that. So I will just substitute z is equal to this. So before that I can take 36 outside. So if I take 36 outside, I can take a 6 outside. So if I take 6 outside, we will have 6z minus 6 plus 3y. So I am not sure that in first octant z is equal to 0. So I am just keeping z as it is. So this z will get cancelled. So now we will transform z in terms of x and y, right. You just substitute by putting z is equal to 0 and then integrate. So but now I am not going to do that. So I can replace 6z is equal to 12 minus 2x minus 3y. So this will be double integral over here. So in place of 6z I am going to write 12 minus 2x minus 3y minus 6 plus 3y. So this 3 by 3 will get cancelled. So we have only 12 minus 6 is 6. So we have 6 minus 2s. So this will be double integral over s 6 minus 2x into, we will write dy dx, because we know x limit. So x limit will be a number. So this will be 0 to, so we have found x limit to be equal to 0 to 6, right, 0 to 6, because the surface is 2x plus y plus 3z, right, 2x plus y plus 6 is 2x plus 3y plus 6z is equal to a surface. To find the x limit, put y is equal to 0, z is equal to 0. So we have this to be equal to 2x is equal to 12, that means x is equal to 6. So the x varies from 0 to 6. Now we need to find y limit, right. Yes, now we can use the concept to find y limit. So we have to find y limit. So in first octant, right, in first octant, so 2x plus 3y plus 6z is equal to 12. in first octant this will be 0, right? In first octant this will be 0. So we have 2x plus 3y is equal to 12. That means 3y is equal to 12 minus 2x. That means y is equal to 12 minus 2x by 3. So I'll tell you one more shortcut also. If you want to find x limit, you put y is equal to 0, z is equal to 0. That means the right to it put 0 just for the shortcut, right? If you want to find x limit, put y is equal to 0, put z is equal to 0. If you want to find y limit, you just have to put z is equal to 0. You should not put x is equal to 0, right? So we will have y limit in terms of x. Suppose if you want to find z limit, there is no next variable next to z. So that means 6z is equal to 12 minus 3x minus 6y. So again I will tell you the shortcut. To find x limit, put y is equal to 0, z is equal to 0. To find y limit, put z is equal to 0, right? And to find z limit, you just transform everything in terms of z from this equation. So this is a very important trick that will be useful in volume integral, right? So if you have 3 or 4 variables, if you want to find the limit of the first variable, you just put every other variable next to it equal to 0. If you want to find limit for 3y, you put the next variable next to 0. So if you want to find z, there is no variable next to it. That means 6 is equal to 12 minus 2x minus 3y. So the y limit will be 12 minus 2x by 3. So 12 minus 2x by 3. So this will be integral 0 to 6, integral 0 to 12 minus 2x by 3, 6 minus 2x dy dx. So you always interchange the limit, right? So you just see which is number, so you just change that to dy dx or dx dy. So this will be integral 0 to 6, so there is no y here, so 6 minus 2x is constant. So integration of dy is y, so we have 12 minus 2x by 3 into dx. So I can take 1 by 3 outside. So when I simplify this, this will be 6 into 12, 6 into 12 is 72, 6 into minus 2 is minus 12x, and this is minus 24x plus 4x square dx. So we will integrate this, so this is 1 by 3, integral 0 to 2x, 72 minus 36x plus 4x square dx. So just integrate this and then substitute upper limit and the lower limit. So we get the answer to be equal to 24, right? 24. So these are very easy process, right? 72. So upper limit and lower limit will be 24. So once I will give us exercise. So evaluate double integral over s f dot n ds, where over the surface of the cylinder x square plus y square is equal to 16 in the first octant between z is equal to 0 and z is equal to 4, where f is equal to z I vector plus x j vector minus y z k vector. This is the first. This is a similar problem that we did in the first problem. So they are given the cylinder x square plus y square is equal to 16. Now we can take dx dz or dy dz. So just take a dx dz, right? So ds to be equal to dx dz by n dot j. So you can see z limit is from 0 to 4, and for finding x limit you have to put y square, y is equal to 0, right? That means y is equal to 0 means x will be 4. So limit is from x is equal to 0 to 4, again z is equal to 0 to 4, and you just find n. So n is nothing but 2x I vector plus 2y j vector divided by square root of 2x whole square plus 2y whole square. So if you do that, you will get n dot j, and then you substitute here, integrate it, you will get the required answer, right? So this is similar to the first problem which we did. So you will get the answer to be as 42. So now we'll move on to volume integral, right? Actually, it's a very rare. So just for the just in the syllabus, I'm just doing this. So volume integral. So straight away move on to the problem. The first problem is evaluate triple integral. So volume is triple integral over V f dot dv f dv, where f is equal to 45 x square y, and v is the actually volume integral is very easy, right? So if you find only the limits, it is done. So it is not like line integral or surface integral. So only thing is you need to find dv. So dv is dx dy dz. The only thing is you need to find the x limit, y limit, z limit, then you are done. You just have to integrate thrice to get the required answer. So f is equal to 45 x square y, and actually line integral also very easy, volume is also very easy. The only thing you need to practice is surface integral, and V is the closed region bounded by 4x plus 2y plus z is equal to 8, x is equal to 0, y is equal to 0, z is equal to 0. Now we need to evaluate triple integral over V f dot dv. So dv is nothing but dx dy dz, right? So f is 45 x square y, dx dy dz. dv is nothing but dx dy dz. And again, as I said, we can easily find x limit, y limit, z limit, right? How you will find x limit, y limit, z limit? So you can see, to find x limit, what you will do? To find x limit, so what are the variable next to x? It is yz. That means you put y is equal to 0, z is equal to 0. So we have 4x is equal to 8, that means x is equal to 2. So therefore x limit is from 0 to 2. Now to find y limit, what are the variable next to y? It is only one variable, so put z is equal to 0. So we have 4x plus 2y is equal to 8. So that means 2y is equal to 8 minus 4x. So that means y is equal to, if I take 2 outside here, you will have 4 minus 2x. So this 2 will get cancelled. So therefore the y limit is from 0 to 4 minus 2x. 0 to 4 minus 2x. Now to find z limit, so you can see there is no other variable next to z variable, right? So therefore you can take, if you have to bring every term to this side, so we will have 8 minus 4x minus 2y. So this is the z limit. That means z limit is from 0 to 8 minus 4x minus 2y. So we have found x limit, y limit, z limit, and you can see the number is 0 to 2. So just you just write x limit here. So if you are writing x limit, Actually, you just write like this, right? You just write like this. In book, they will not give like this. Simply, in the next step, they will simply write the limits like this. They will not, in book, they will not give explanation of how they are finding the limit, right? So, it's nothing. The clue I am giving. In none of the book, you will find the steps for calculating limit. So, after this step, they will simply write the step which I am going to write, right. So, this is the extra thing you are writing. In exam, you don't need to write method for calculating limit, right. After this stage, you can simply write the step I am going to write now. So, this means, so this will be integrals. You can see the number is dx. So, what we will do is we will transform to dz dy dx. So, we will transform this to 45x square y dz dy dx. You just make dx to be the last term because x only will have number. So, we have this to be 0 to 2 and y limit is from 0 to 4 minus 2x and z limit is from 0 to 8 minus 4x minus 2y. Actually, in book what they will do is after this step they will be writing this step. Actually, it is visible, right? I think it is not visible if I write there. So, what I will do is I will write here. So, this will be triple integral. So, we will just 45 x square y, we will transform this to dz dy dx, and you can see x is from 0 to 2, y is from 0 to 4 minus 2x and x is from 0 to 8 minus 4x minus 2. So, in book what they will do is after this step you will, in book they will directly write this step, right. So, it is not necessary that you have to write this procedure in the exam, right. Yes. So, we just have to integrate and then we need to substitute upper limit and the lower limit. So, you can see this is independent of z. So, this will be integral 0 to 2, integral 0 to 4 minus 2x. So, 45 x square y I can take constant, integral dz is z. So, upper limit is 8 minus 4x minus 2y dy dx. So, when we will multiply inside, so this is 0 to, or else we just write x is equal to y is equal to, just for your understanding. So, this will be, so when you multiply this you will have 45 into 8, or else you will take 45 outside, So, x square into y is 8 x square y, x square into 4x is minus 4 x cube y and minus 2 x square y square dy dx, right. I have taken 45 outside, x square y is 8 x square y and where we are transforming. Without transforming, how you will find z limit, y limit and x limit? You need to find limits, right. So, this will be 45, this will be x, will be from 0 to 2. So, 8 x square. So, when I integrate y square, so it will be y square by 2, be 0 to 4 minus 2x and again minus 4x cube and integration of y is y square by 2, 0 to 4 minus 2x minus 2 x square y cube by 3, 0 to 4 minus 2x dx. Now, you want to apply upper limit and the lower limit. So, actually lower limit is 0. The only thing is you need to apply upper limit now. before whatever or else you know I can also do, we will take we have y outside, right? We have y common here, so we will write 8x square minus 4x cube. We will take y and then integrate, right? So if we take y, this will be y square by 2. So I have taken 8x, this is x limit. So before integrating, I have taken 8x square minus 4x cube. So if we integrate y, we have y square by 2, 0 to 4 minus 2x minus 2x square y cube by 3, 0 to 4 minus 2x dx. Now we need to apply upper limit and the lower limit. So this will be 45 integral 0 to 2, integral 0 to 2, and this will be I can take 2, I can take 2 cancel here. If I take 2 outside here, we will have 4x square minus 2x cube, and this 2 and this 2 will get cancelled. So we have y square. So y square is 4 minus 2x whole square. Again here we have minus 2x square by 3 into 4 minus 2x whole cube. 4 minus 2x whole cube. Now you can see we need to integrate this. We need to make a minus b whole square formula and a minus b whole cube formula. You have to expand this and then you need to simplify. So what I will do is you can see if I can take a x, so this will be 0 to 2. If I take x square common here, we will have 4 minus 2x. Again here we have 4 minus 2x whole square minus 2x square by 3, 4 minus 2x whole cube, right? I have just taken x square common here. Now I can take 4 minus 2x whole cube common. Here we have 4 minus 2x whole cube and here we have 4 minus x whole cube. So we have 25. If I take integral 0 to 2, I take 4 minus 2x cube whole cube common. So this 2 term will be vanished. So we have only x square here and here we have 2x square by 3. So this will be 45 integral 0 to 2, this will be 4 minus 2x whole cube and 3x square minus 2x square, which is nothing but x square by 3 dx, x square by 3 dx. Now we need to integrate this again. So before integrating, we will apply a minus b whole cube formula and then we will substitute and then we multiply x square by 3 outside. I can also cancel 3 and 45. So we have 15 integral 0 to 2 4 minus 2x whole cube into x square dx, x square dx. Now okay, we need to apply a minus b whole cube formula, right? So a cube minus 3a square b plus 3ab square. So a minus b whole cube, a cube minus 3a square b plus 3ab square minus b cube. So here a is 4 and b is 2x. So I think you can do now, right? So there will be 4 terms here and then you multiply x square to all the 4 terms and you just find upper limit minus lower limit. You will get the answer to be equal to 128. So now we'll move on to the next problem. if f is equal to 2x square minus 3z I vector minus 2xy j vector minus 4x k vector, evaluate triple integral over v del dot f dv. So there we have only f dv. Here they asked us to find del dot f dv, where v is the closed region, bounded by x is equal to 0, y is equal to 0, z is equal to 0, and 2x plus 2y plus z is equal to 4. And also evaluate triple integral over v del cross f dv. So we need to find 2, right? Suppose we will find del dot f dv. So del dot f is nothing but divergence, right? So del dot f is divergence. So first we will find del dot f, right? So triple integral over v del dot f dv. This is nothing but triple integral over v. So del dot f. So find divergence for this. So the first component with respect to x. So we have 6x, right? 4x. Second component with respect to y. So we have minus 2x. Third component with respect to z. So we have 0. So dv is dx. So straight away write dz dy dx. So I am just finding divergence for this. Del dot f is divergence, right? Because we have dot here. We don't have dot, it is gradient. Here we have dot, right? So it is nothing but divergence. So for divergence, you will differentiate partially the first component with respect to x, second component with respect to y, third component with respect to z, right? So this is nothing but triple integral over v 2x. So I can take 2 outside. So x times dz dy dx. Now we need to find the limits, right? Now we find the limit. So I think you can easily find limit, right? How you find limit? So in order to find x limit, you just put y is equal to 0, z is equal to 0. So we have 0 to y is equal to 0, z is equal to 0. That means 2x is equal to 4. That means x is equal to 2. Therefore x limit is from 0 to 2. So for y limit z is equal to 0. So we have 2x plus 2y is equal to 4. That means 2y is equal to 4 minus 2x. So if I take 2 outside, we will have 2 minus x. So therefore y limit is from 0 to 2 minus x, and clearly z limit is from 0 to 4 minus 2x minus 2y. So this will be 2 times integral. So x limit is from 0 to 2, y limit is from 0 to 2 minus x, z limit is from 0 to 4 minus 2x minus 2y dz dy x into dz dy dx. So you just have to integrate now. So when you integrate this, so we integrate this. So 2 times integral 0 to 2 minus x. So we have a dz. So x into integration of z is dz is z. So we have x times 4 minus 2x minus 2y dy dx. So this 2 times integral 0 to 2 minus x. This is 4x minus 2x square minus 2xy dy dx. Again you can see only so integral 0 to 2. So in indirect respect to y, we have 4x and we have y. So integral dy is y. So when I substitute upper limit, we will have 2 minus x, 2 times x square, or we will write, okay, 4x, this is 2 minus x, so because integral dy is y, again 2x square is constant, integral dy is y, so upper limit is 2 minus x minus 2x y square by 2, 0 to 2 minus x dx. This two will get cancelled. So we have 2 times integral 0 to 2, and again if I substitute upper limit, you will have 2 minus x whole square. So if I take 2 minus x common, here we have 4x, here we have 2x square, and here we have 1 2 minus x, because here we have 2 minus x whole square. So we have taken 1 2 minus x outside, so we have 1 2 minus x here into dx. So this is 2 times integral 0 to 2 minus x, and this is 4x minus 2x square minus 2 plus x, So this will be 2 times integral 0 to 2 minus x, sorry, where you have x, right, x. So this will be 4x minus 2x square minus 2x plus x square, so minus 2x plus x square. So 2 minus x into x square, so 4x minus 2x is 2x, this will be minus x square plus 2x. So this will be 2 times integral 0 to 2 minus x. Again I can take x common here. So if we take x common here, again we have 2 minus x. So this is nothing but 2 minus x whole square into x. Okay, we will straight away multiply. So when I multiply this, we will have minus 2x square, plus 4x, and this will be plus x cube minus 2x square. So this will be 2 times integral 0 to 2 x cube minus 4x square plus 4x into dx. So into dx. So this will be 2 times, so x power 4. So we have a x power 4 by 4. So we have 1 by 4. X power 4 is 2 power 4. So 2 power 4 is 32 minus 4 times x square is x cube by 3. So x cube by 3 will be 2 cube by 3. So 2 cube by 3 is 8 by 3 plus 4 times we have x square by 2. So x square by 2 is 2 square by 2. So 2 square by 2 is 4 by 2. So we have 2 times 2 power 4. 2 power 4 is 16, right? So this will be 4, and this will be 32 by 3, and this will be plus 8. So we have 2 times 4 minus 32 by 3 plus 8. So I get here. So this will be 2 into 4 minus 32 by 3 is 12 minus 32 by 3. So 12 minus 32 by 3 is minus 20 by 3 plus 8. So this is 2 into minus 20 plus 24, so which is 4 by 3, minus 20 plus 24, so which is equal to 8 by 3. So 8 by 3 is the required answer. Now they have also asked us to find triple integral over V del cross f dv. So that means first we have found divergence, right? So for divergence we have got x, I think, right? Yes. Now we need to find the curl, and then we need to integrate. We need to triple integrate. So second part is So second part is we need to calculate triple integral over V del cross f dv. So just find del cross f now. So in the first part we have found divergence del dot f. Here we are going to find a curl. So del cross f. So just think but I j k dou by dou x, dou by dou y, dou by dou z, and what they have given f? They have given f as 2x square minus 3z I vector minus 2xy j vector minus 4x k vector. So you just expand this determinant. So you will get the answer as j vector minus 2y k vector. Now you take this as del cross f and then you apply the same procedure which we did, right? So in the previous divergence we have 2x. So we have 2x, del dot f is 2x. Here we are going to have j minus 2y k vector, j minus 2y k vector. So this will be just find j vector minus 2y k vector minus 2y k vector dz dy dx. The limits are same, right? So what are the limits we have found? 0 to 2, 0 to 2 minus x, 0 to 4 minus 2x minus 2y. Limits are same. The only thing is here in the previous in the first subdivision we have 2x. Here we are going to have j vector minus 2y k vector. So you just multiply dz. So we have j into z, j into z. So j into upper limit minus lower limit minus 2y. So I can take this as constant, right? You can take this as constant when you are integrating with respect to z. So we have this into this. Now you make some simplification. Integrate with respect to y. Substitute y is equal to 0 to 2 minus x. You will get the answer as 8 by 3 j vector minus k vector. Right? The only thing is you need to integrate. The only formula I am going to use is x power n formula. So you are going to use x power n formula and you are going to apply upper limit and the lower limit. So I'll give you one more problem for practice and then we'll wind off. So one problem from a volume integral. So just have to practice more problems. So there are only 4 problems of volume integral in the book. So I'm already sent the PDF in the Telegram group. So you just have to follow all the problems. So in the first 45 problems are line integral and next 20 problems are surface integral and volume integral. So here I'll give one problem for exercise. So evaluate triple integral over V f dot dv where f is equal to xi vector plus yj vector plus zk vector and V is the region bounded by the surface x is equal to 0, x is equal to 2, y is equal to 0, y is equal to 6, z is equal to 4, z is equal to 4 and z is equal to x square. So that means actually this is a long process, right? Because this integral involve x, y, j. So it will take many time more. It will consume more time. So you can easily calculate limit, right? So they have already given that. Let us say this is f dot dv and this is x is equal to 0 to 2, y is equal to 0 to 6, and they are given z is equal to 4 to x square, right? Z is equal to x square to 4. So you always write a variable as a lower limit, right? So z is equal to x square 4 and f dv. So f dot dv. So dv is dx dy dz. So this is xi plus yj plus zk dx dy dz, or you will write dz dy dz dy and dx. Now this will take more time because you can see this involves 3 variables. So what we will do is we split this into I1, I2 and I3, right? I1, I2 and I3. So I1 is in triple integral xi dx dy. Okay, we will write this as I1 I plus I2 j plus I3 k. So just find I1, I2, I3 and then you substitute there, that's it, right? So x dx dz dy dx, this is our I1, and I2 is triple integral y dz dy dx, and I3 is triple integral z dz dy dx, right? So you just find I1, I2 and I3. So the limits are same, 0 to 2, 0 to 6, x square to 4, 0 to 2, 0 to 6, x square to 4. So you will find I1, I2, I3, you will have this to be some number, this to be some number, this to be some number, and then you substitute in I1 I plus I2 j plus I3 k. So you just name this to, so you just name this as, this is equal to I1 I vector plus I2 j vector plus I3 k vector, where I1 is triple integral over x, triple integral over y is iz, triple integral over z is I3. Now we can easily find I1, I2, I3. So I just tell you the answer for I1. The answer is 24. Actually it's very easy, you just have to integrate using x power n formula, right? This is 24 and I2 will be 96, I2 will be 96 and I3 will be 384 by 5, right? 24, 96, 384 by 5. So you just substitute I1 to be 24, I2 to be 96 and I3 to be equal to 384 by 5. So the entire integration answer is so I'll repeat, I1 is 24, I2 is 96, I3 is 384 by 5. So substitute here, we will have 24 I vector plus 96 j vector plus 384 by 5 k vector, right? So that's it. So we'll see the next video. Thank you.